Hey, it's Mrs. Mallet again, and what we're going to talk about right now is the quotient rule for exponents. Alright, so the quotient rule for exponents states that you look at your like bases. Remember quotient rule, kind of set up like division or fractions, okay? So you look at your bases and now you're going to subtract your exponents. But let me show you the long drawn out reason why. Let's say that I have x to the sixth over x to the third. Let's actually expand this out so I can show you why we subtract. Okay, so I have 6x's up top. 1, 2, 3, 4, 5, 6. Now I have 3x's on the bottom. Let's cancel what we have the same number on the top and bottom. So notice I can only cancel out 3 of them, which leaves me with 3 left over on the top. Okay, so this now is x to the third power. So see, notice the rule. What you do is you look at your bases, you keep your like bases, and now you're going to subtract your exponents. If you have to starting off and want to expand it out like I did, that's totally fine. You can do that. But remember your rule. Quotient rule, subtract your exponents. Now let's do a couple of more examples. Let's say I have z to the 9 over z to the 7. Okay, so you can expand this out if you want to, which is totally cool. But remember, quotient rule, subtract your exponents. So this will be z to the 9 minus 7. Well, what is 9 minus 7? You're right, it's 2. So this will be z squared. Now don't make fun of my z's. I have to draw a line in them so people know they're not 2's. Alright, moving on. So let's do another example. Let's say I have negative 3 to the 7th over negative 3 to the 4th. Same rule applies. Subtract your exponents. So this will be negative 3 to the third power. Now what is that? Let's actually do that. What is negative 3 to the third power? Well, 3 times 3 is 9. 9 times 3 is 27. So this will be negative 27. Final answer. Alright, what if I have something like this? X to the fourth over y to the third. Can I do this? No. You're absolutely right. I can't do this because I don't have like bases. I have an x on top and a y on the bottom. Nothing about that says a like. So you'll just leave it like that. You can't do nothing with this because there's no like bases. And remember, you always need to be looking to see, do they have a like base so that you can work with them. Alright, let's try a harder one. Alright, let's say I have 6x to the third, y to the 7th, over x, y to the 5th. Okay, so same rule applies here. You look at your bases and subtract your exponents. Alright, so now let's look at the number. Remember that number I called the coefficient in one of my earlier videos? That's what this is. It's a coefficient. Now what number is in front of this x right here? You're right, a 1. Bring out your 1 if you have to. Sometimes you don't have to, but sometimes you do. So bring it out so you can look at it. Alright, so 6 divided by 1 is 6. So I have 6x to the, now here, right here in front of this x, if you have to bring your 1 out there too, that's totally fine too. But you only have one x. So remember your quotient rule, subtract your exponents. So 3 minus 1 is 2. And y to the 7 minus 5, which is also 2. So your final answer would be 6x squared y squared. What we just talked about today was the quotient rule for exponents.